Hello friends, welcome to our class on races. These are a class of quantitative aptitude problems. So this is the basic formula, this is the basic concept. Speed is equal to distance into time, which is used by all the problems in all the race problems. So this is how this class fits in our overall strategy. We will be taking several classes which cover the race and speed problems. Right? And today we would be discussing problems which involve head start and linear track. Right? Head start and linear track, which means the track which goes straight. Later on we will be covering circular tracks and we'll understand how clocks fit into this overall scheme of things. So let's start. So there are two concepts involved in all race problems. I mean, you should understand these two concepts. One is the concept of a dead heat. A dead heat means that all the participants in the race reach the finish line at the same time. That's what is dead heat. And then the second concept is head start. Head start means that a participant is given more advantage over other participants. Right? So there are two participants. There are two participants A and B. A is allowed to, let's say, start first, and that means that A is given the head start. So this is an example. Here these two participants are stuck on the start line, whereas these two participants started early. So they were given advantage or head start. Now the head start can be, right, so clearly distinguish these two things. The things that I am telling you now. The head start can be in terms of time or it can be in terms of distance. They are two distinct things. This particular head start shown in this diagram, this figure, is in terms of time, which means these two participants started early and these two participants will start late. They would cover the same course length. Right? They would cover the same length. They would cover the same distance. Another kind of head start we can imagine is in terms of distance, which means that two participants start from different locations on the track. Let's say A starts from here and B starts further down the track, and hence B is being given the head start. He is being given advantage over A. Right? We say it as A gives a head start to B, and this head start is in terms of distance. Right? When the starting pistol is fired, these two participants would start running at the same time, but they would be running from different positions and they would end up at the finish line. This is the same finish line for both of them. Okay? So if the head start is in distance, time remains same. Right? That is that they start at the same time. If it's in terms of time, then they cover the same distance, and distinguish this. Right? And keep this in your mind. This is very important. Similarly, at the finish line, there can be two different things. Either we can say that a participant won by certain margin of distance, let's say this much distance, right? Maybe let's say 10 meters, or I can keep time. Right? I can keep time. I can say that, oh, this participant crossed the finish line, let's say at 10 o'clock, and this participant took 2 more seconds. Right? So I can either give the participant who won the race, I can specify that in terms of time, margin of time, or I can specify in terms of margin of distance. When I am specifying in terms of margin of distance, let's say 10 meter, it means that these two participants were at these positions at the same instant of time. They were just at different locations. When I am giving the margin or the winning margin in terms of time, that means that these two participants cross the same distance. These two participants move the same distance but at different times. So again, this is what this is summarized, and finally we come to this slide. Right? So if you have to keep this slide in mind all the time, always keep this in mind, right? And do not confuse times and distances. That is the key here. Now on this problem we will apply our knowledge of this distinction between time and distance, we'll apply that to draw two kinds of diagram, time diagram and distance diagram. And just by using these two diagrams, we will be able to solve each and every problem. I guarantee you that if you clearly specify these two diagrams, you will be able to solve all the problems on races. So let's see how to use these. It's a 2000 meter race. So let's draw a distance diagram, and on this side I would be drawing a time diagram. We would be seeing what it means in just a second. So distance diagram is simple, it's fairly obvious. So this is a 2000 this is the 2000 meter race. So the entire track is 2000 meter. A gives B a head start of a minute, but still beats him by 200 meters. So we ignore all the times when we are drawing the distance diagram. We will only concern ourselves with the distances. Right? So what this says that when A reaches here, A and B, they start from the same point, right? There is no head start in terms of distance. The head start is in terms of time. So they start from the same point, but A covers this 2000 meters, okay, and reaches A dash, and when he reaches A dash, B is here, beats him by 200 meters. So B is still 200 meters behind. So this is what this is telling me. This is 200 meters. So obviously this is 1800 meters. Clear, right? So now this is the distance diagram. Let's see how this thing looks in terms of time. So what is the first thing that happens? A gives B a start of a minute. So who goes first? B goes first. B has been given advantage here, and after some time, which is 60 seconds, A starts, and then they both are running, and finally they reach certain configuration after A has finished the race and B is 200 meters away from the finish line. So this is the time at which A finishes the race. So this is now my time diagram. So what is A dash? What is the time it takes A to cover this entire distance from A to A dash? What's the time? Let's assume that the speed of A is small a and the speed of B is small b. Then I can write that A dash, this time is 2000 meters. That's the distance that A has covered with the speed of A. And what's the time B took to run his 1800 meters? He took 1800 divided by B seconds. Right? So this is my time diagram. This is the time B took, this is the time A took, and here is the advantage that B was given. So now with this time diagram, I can write a equation. Right? Now with this diagram, I should be able to write a equation. And what does the equation say? 1800 divided by B, this much, minus 2000 divided by A is equal to 60 seconds. Very simple. As soon as I have this diagram, I can write this equation. Right? But there are two distinct concepts, time, distance and time. Now let's see another one. Let's see what happens in the second case. I'll rub this. In the second case, we know that the race ends in a dead heat, which means they are both covering the same amount of distance. It's just that one of them started first. So again, B started first, so I'll put B, and then after a while, how much while? 80 seconds, A started, and so I'll put A, and then they finished at the same time. This is dead heat. Dead heat means that they reached the finish line at the same time. So this is 80 seconds. Now again, how much distance A is covering? A is covering 2000 with the speed of A. So this is the time A will take to cover his 2000 meter, and of course B is slower, so B would cover his 2000 meter in this much time, and he'll negate the advantage of 80 seconds to meet A at the finish line. So this is my second time diagram, and from here I can derive my other equation. 2000 divided by B minus 2000 divided by A is equal to 80. Very simple, right? So with this diagram I can come up with this equation. Now one thing which I want to tell you is what happens if we subtract these two equations. If we subtract these two equations, then A vanishes and I am left with this term with A vanishes, only B. So I can simply solve for B here, and B would come out to be 10 meters per second. And finally I can solve for A also, which comes out to be 16.67 meters per second. So this is my final result. Two equations, two unknowns, I can solve it. Right? So if I go by these first principles, I draw all my diagrams, I can easily solve this question in under a minute, easily, because the maths is not difficult, it's very simple. So I should be able to do that. But if you notice one thing here, there is a trick here, right? I mean, we can use a kind of shortcut here. And what is it? Let's look at this thing a little more detail. Let's look at this in little more detail. There is a head start of a minute here, 60 seconds, and this was increased to a head start of 80 seconds, and this additional 20 seconds enabled B to cover this 200 meter. This additional 20 second of head start enabled B to cover this 200 meter, the 200 meter by which he lost the first one. Therefore, speed of B is equal to 200, right, divided by 20 meters per second, which is equal to 10 meters per second. So I can directly arrive at the speed of B. This is kind of a shortcut, but this shortcut does not work all the time, whereas our first principle method, our diagrams, our equations, they work all the time. So I should always use these, right, the diagrams and equations, right, and not look for shortcuts. If naturally by practice they come to you, well and good, otherwise don't worry. Even these diagrams and these equations would enable you to solve this question relatively quickly. So moving on, another very similar example, right? I mean, I'm taking another similar example to illustrate two things. First, there are no shortcuts here. We have to write the full equation. Second, we'll just have to practice. We'll just practice our time and distance diagrams one more time. So let's start. 2000 meter, again the race is the same. It is again 2000 meters. So I am going to draw my distance diagram. A gives me a head start of 200 meter. This time the head start is in terms of distance. So A starts from here, B starts 200 meters further down the track. So B starts from here, and then finally they arrive here and beats him by 30 seconds. Beats him by 30 seconds means that A and B both reach the finish line. A goes first. After 30 seconds, B crosses the finish line, but they both cross the finish line, so they have covered the same distance, right? In the sense that they have reached the same point in the end. So this B dash is 1800 meters. Now let's draw my time diagram. How does my time diagram look? Very simple. A and B, so they start from at the same time, right? They are starting from different locations, but from the same starting pistol. When the shot is fired from the pistol, they start at the same time. So they are starting from at the same time. This is the time diagram. Remember, I am depicting time here. This is the timeline. And what happens in the end? First A reaches, and I am standing there at the finish line. What will I see? After 30 seconds, B reaches. So this is how my time would look. Can I put more numbers here? can I demarcate this distance? What is the time A took to reach the finish line? If speed of A is small a, then he took 2000 by A. What is the time B took? 1800 by B. So far, so good. Now with this I can write my first equation. 1800 divided by B, this is B, minus 2000 divided by A is equal to 30. Very simple, right? So we arrived at our first equation. Let's see what happens in the second case. Now in this case, the head start is in terms of time, 3 minutes, which is 180 seconds. So let's draw the distance diagram first. Beaten by 1000 meters. I am not worried about this yet because this is distance diagram. So distance diagram, what will I draw? A covers 1000 meters. A dash. B again. This time the head start is in terms of time. So they start from the same location. They start from the same start line, but at different times. So B covers the entire distance. B covers the entire distance. B dash, this is entire 2000 meter, and of course this is 1000 meter. Now what would my time diagram look like? Who starts first? B is been given the advantage here, so B would start first. 180 seconds later, A would start, and when B crosses the finish line, this is the time when B crosses the finish line, and there is some energy. So what is the amount of time B took to cross the finish line? I know he is covering entire 2000 meter at the speed of B. What is the time A? What is the time between A is starting and B crossing the finish line? I know that A has only covered 1000 meters at the speed of small a. So this is my second equation. Let me write that down. Now again I have two equations and two variables. I can solve them, and finally what will I get? B is equal to, that is B, the speed B would come out to be 20 by 3, speed A would come out to be 25 by 3, and the time, this is asking the time, how many minutes they race separately, the times would, respective times would come out to be 5 minutes and 4 minutes. Right? So you can solve these equations yourself and get here. With these diagrams, we were able to arrive at these equations very quickly. Right? That is the key. Moving on, this is a relatively simple question, right? I mean, we have done two very difficult problems already, so we are all set actually. Right? With these basic concepts, we can solve these other questions that I am going to go through very, very quickly. A runs 50% faster than B, so A is running faster than B. So if B runs at the rate of x, A is running at the rate of 1.5x. That is what this thing is telling me. A gives a head start of how much? 7 meters. Okay. And the race ends in dead heat. So head start is in terms of distance. Dead heat means that they reach the same end point at the same instant of time. Right. So let me draw that distance diagram very, very quickly. So this is A, this is B. B is here, 7 meters, right? This is the head start, and then this is the finish line. They reach the finish line at the, this is common to them, and they reach this finish line at the same time. And if this entire length of track, let's assume it is L, then this becomes L minus 7. This is the distance B has covered. Now, what happens? What about my time diagram? My time diagram would look very simple. When the shot was fired, they both started and they both finished again at the same time. Right? They might have started from different positions, but they started at the same time and they finished at the same time. So my time should be equal. What does that tell me? It tells me that L minus 7, this distance which B covered divided by x is same as the distance covered, the time that A took, L divided by 1.5x. Now x and x cancel out. I can solve it for L, and L will come out to be 21 meters. Now again, this is not very complicated. You can easily use this method and do this question in under a minute. But if you really want to read more into this question, if you really want to do careful analysis of this question, there is a shortcut kind of thing here also. Right? And what's the shortcut? Let's see, if we assume that the length of track is 1.5 meter, right? The shortcut can come from here actually. We can derive the shortcut from just by looking at this diagram. So A could cover this 1.5 meter and B would only cover 1 meter because B is running right at x speed. So B would cover only 1 meter. So how much head start should we give to B so that the race ends in dead heat? We need to give 0.5 meter to B, and if we do that, then they both reach the end point at the same time, right? So now with this, what do I know? If I give a head start of 0.5 meter, my track length could be 1.5 meter, or on a track length of 1.5 meter, this is the head start, I gave 0.5 meter. Similarly, if I gave a head start of 1, my track length could be, and if I gave a head start of 7, my track length could be 1.5 divided by 0.5 into 7, which comes out to be again 21. So this is a slightly shorter method of doing the same problem. But if don't waste time arriving here, with enough practice, maybe naturally you will come here, and that's okay. But until and unless you come here, you should use this first principle method, which is applicable to any and all problems. You should master this. That's the key. Moving on. Again, we are given two people, A and B. Speed of A is 20 by 19 times. So let's say that speed of A is 20x. Then speed of B becomes 19x. Okay, so this one is saying that race ends in a dead heat. So let's try to draw a diagram here. If the length of the track is L and I am required to give a head start to B, right? Head start L into A, right? A is the fraction of the length of the track which I am giving to B. So the length of the head start becomes L into A. This is the head start I need to give to B so that they reach the end point, the finish line at the same time, and this is what the question is asking. Right? And this becomes 1 minus L into A. Okay. So now again my time diagram would look very similar to last one. They will start at the same time. I am not giving any head start in terms of time, and then they will finish also at the same time. So the time is same. So I can equate the time and I can say 1 minus LA is the distance covered by B. Sorry, L minus LA. L minus LA is the distance covered by B divided by the speed of B, which is 19x, should be equal to LA or full length L, which is covered by A, full length L, divided by the speed 20x. X and x cancel, L and L also cancel, and finally my A would come out to be 1 by 20. So this is the fraction of the length of the track that I need to give to B so that they both reach the finish point at the same time. Now the second part of the question is asking me a slightly different thing, right? What is it saying? That I don't want them to reach at the same location. What I want is for A to win. So when A reaches the finish line, B should be 0.05 L away from the finish line. This is B dash. So again, this is the same instant of time. They are starting at the same instant of time. So I can equate the time. L minus LA minus 0.05 L. This is the distance covered by B now. B is covering a smaller distance than last time, right? Because I want A to win. And then again on this side everything remains the same, and finally here my A comes out to be 0. What does that mean? It means that there should not be any head start. There should not be any gimmicks here. Let them play fair. That's the thing. And finally, the third thing is I am reversing it. Now I want B to win. So now here B reaches the finish line, and when B reaches the finish line, A should be here. A should be here. So A should be how far? 0.1 L. That's it. This is the entire length L, this is LA, and this is the 0.1 L. So now how much distance B has covered? B has covered distance from here, this distance L minus LA, this entire distance B has covered. And how much distance A has covered? A has covered distance from here to here, which is L minus 0.1 L. And again x and x cancel, L cancel, and you can do the maths. Finally your A would come out to be 0.145. Right? So here, right, I wanted this question to be in 3 parts to illustrate how we are fudging the distances, how we are simply changing the distances. The time can always be equated because this was a dead heat. They are starting from the same, they are starting at the same time, they are ending at the same time. That's the thing. Now this one is the next 3 questions, right? These are our 3 final questions, are slightly trickier. They are trick questions in the sense that you can write equations, but maybe they are not going to help you as much. You have to realize a few things. 100 meter A beats B by 10 meters. So when A covers 100 meters, B covers 90 meters. Now in the scenario given in the question, what is happening? B is starting further back. He is moved back from the start line by how much? 10 meters. Right? So sorry, B not B, A is moved further back. A starts 10 meters behind, and B is starting from the same location. So now when B has covered 90 meters, A would have covered how many meters? 100 meters. But we know that B, when A is 100 meter and B is 90 meter, they happen at the same moment in time, right? When A covers 100 meters, B can cover 90 meters. So if they start together, they would reach this place, this common place, 90 meter away from the start line at the same time, right? So they reached here at the same time. Now this becomes our new, assume that this becomes our new start line, new fair start line. And now let's see what happens. This start line is 10 meters away from the final finish line. We'll draw it using 2 bars here, 10 meters away. So A can cover this 10 meters, and when A covers this 10 meters, how much B would have covered? Only 9 meters. So B would have reached somewhere here, B double prime, and A would have reached the final finish line. And this difference would be how much? 10, 9 minus 10 is 1 meter. This difference would be 1 meter. So A would again beat B by 1 meter. That is the answer. Moving on, next question. Here we are given three things, A, B and C. Three participants are there. Right? First A and B run, and then A beats B by 1 minute, then B beats C by 30 seconds. So if A and C were running, then by how much A would beat C? A would beat C by 30 plus 60. This is 60 seconds, 90 seconds, right? So let's draw a time diagram. A and C start from the same time, and then first A would reach, after a while C would reach. How much? After 90 seconds. Right? That is the first diagram. Now we also know that A beats C by 250 meter on the same track. So let's see. This is the distance diagram now. When A reaches the finish line, C is where? C is 250 meters behind. And how long does it take C to cover these 250 meters? 90 seconds. So as soon as you have these two diagrams, you can quickly say that this is the instant when A crosses the finish line, C is 250 meters behind. Now I am waiting at the finish line, C arrives 90 seconds later, which means that C took 90 seconds to cover this 250 meters. So now I know the speed of C. Right? 250 by 90. This is the speed of C. So now I can go back to my first principle, write the equations in both the cases or in one of the cases, and then finally find the speed of A and the answer. I can do that. But there is a little bit of insight here. Just think about it. So it took C, this is 750 meters. We know that because it's a kilometer race, this entire thing is how much? 1 kilometer, which means 1000 meters. We know that. Right? When C had covered 750 meters, A had already reached the finish line. That means that if we find the time it took C to cover 750 meter, we would have found the answer. C covers 250 meters in 90 seconds. We know that. In 750 meters, C would cover in how many seconds? 90 into 3, which is equal to 270 seconds. Very easy, very simple. Right? So just by this little insight, you can solve this problem even quickly. But if you want to solve it using equations, you can do that too. It's not very complicated. Right? I leave it up to you. Now this is the final question that we would be discussing today. And again, it might seem very complicated, but if we draw our distance diagram properly for this question, we'll get the insight required to solve this problem. There are three people now again, right? A, B and C. They start from the same location. Right? There is no head start business. A is the winner, okay? A finishes, and at the moment A crosses the finish line, where is B? 12 meters ahead of B. So B is 12 meters behind. B is right here. This is 12 meters. This is A dash, B dash. 18 meters ahead of runner C, and C is right here. This is 18 meters. Now let's only draw the diagram for what happens when B crosses the finish line. Right? What are we told here? B and C, we are only comparing them. What happens when B crosses the finish line? When B crosses the finish line, C is 8 meters behind. So C is somewhere, let's say here. This is, I'll call it double prime. Right? So B has moved These 12 meters, correct? 12 meters behind, he ran 12 meters and reached the finish line. And during the same time, how much C has moved? This distance is 8 meter. Right? This distance we know is 18 meter. So how much is this distance? 10 meter. So in the same time, right, A, B and C have respectively moved 12 meter and 10 meter. So what's the ratio of speed of B and C? 12 by 10, right? That much I know. Now if the length of this entire track, let's say, is again L, then what else do I know about the ratio of their speeds? Do I know something else? Let's try to find out. Initially, when A reached the finish line, C has covered how much distance? L minus 18, and B has covered how much distance? L minus 12. So what's their ratio of speed from here? It comes out to be L minus 12 divided by L minus 18. Right? Now I have an equation in L, I can solve it, and L would come out to be 48 meters. Right? So again, you would think that there is no way to solve this question, but just by drawing these diagrams, we were able to move forward, make forward progress, right? So diagrams and equations, they are the real friend here. Don't look for special tricks. Special tricks can be applied to one problem but not to another. You'll lose yourself, right? But these first principles, you'll always get an answer, and then slowly and gradually you will start building confidence, you will discover your own tricks, and you will find a way to solve problems quickly. So with this, we cover the first sort of our class on races. In subsequent class, right, in the very next class, we'll talk about races on circular tracks, which get more interesting. Because on in circular tracks, there could be laps. Laps means that the same participants can go around and around many times, and they would start crossing each other. So complicated problems could be formed. And at the same time, we will be discussing relative speed also. So if you like this lecture, then do subscribe to our channel, and good luck. Thank you.